Ever had an electrical fault in your sockets and couldn't figure out what's going wrong? Whether it's flickering lights, dead outlets, or something just not working, diagnosing the issue can be a real headache. In today's video, we're diving into fault finding in socket circuits, and we'll show you how we tackled a tricky ring circuit problem. What's the solution? Well, watch the video to find out.
Hi. Today we've got a fault finding. One of those jobs where we have to find the problem. Alright. So this particular circuit seems to be a ring. So what you do when you're fault finding is you split the ring, and we've done that now, and we've come to this point here. Where we're going to investigate further to find out what is the actual problem. As we've got a spur here. If you just look, that seems to be coming from that area. So stay tuned and watch and see how we get on. So what we're going to do, because we need to put the cable back in there anyway, in that one next door. From here they made a junction box. Alright, so you understand the principle of the ring, yeah? So the ring, two cables come out the fuse board and they join. So we've broken the ring and we found that the fault, we've traced the fault all the way to a particular point in the ring. So one leg is dead and the other leg is live. So as we go along to each socket, we'll find where the problem is and then we'll know what to do. Cool. So what I want to know is this cable that's on the right with that junction, is it from here? And which cable is the one from the, because what they could have done, let me think, use this like this, come here on one side, join it to the other. What's this other one here? This one has only got one, so this one was one circuit that they've extended, and this looks like this is another cable that goes somewhere too and goes down. So this one comes up. Alright, what we're going to do first, I think, let's find out which cable is coming from that end where we've got the spur on the system. So to do that, we're going to disconnect the cables here. We're going to find out which one belongs to the spur, and then we identify which one goes to the fuse board as well. From the fuse board that we think is the end of the ring. So I want to know which is the other end for this. It's just me. Just me. It's alright. This one is the one that's giving the problem. And this one. those two. All right, this one. Put the back in. Where's this going up to? So, this ring was damaged at the first layer. So unfortunately, we can't change the cable so easily. So we're going to downsize the MCB for the protection as we disconnected that leg. If you look at this diagram, you'll see what we've done. Okay, so we've disconnected the ring and we've downsized the breaker to the correct rating as a 20 amp. The leg that's coming from the ring to the fuse board, that's the problem area, so it's not an easy fix. So we've opted to downsize the breaker. I'm going to show a diagram of what we've done. I'll leave it up here.
We're going to take you through how a ring circuit using 2.5mm cable, protected by a 32 ampere type B MCB works. Let's break down the process. First, here we have the consumer unit, which houses the 32 ampere type B MCB. This circuit breaker is responsible for protecting your ring circuit from overloads. It trips if it exceeds the maximum allowance for the fault current, ensuring both the wiring and connected devices are safe. Next, by running the 2.5mm cable from the MCB. This cable is ideal for carrying the required current for standard household appliances, like power outlets and lighting circuits. As you can see, the wire forms a ring, hence the name is ring circuit. The live and neutral conductors run in a continuous loop, starting from the consumer unit and looping around to connect the last socket, which is then wired back to the consumer unit. Now we wire each of the sockets around the loop. Notice how the cable continues from the socket to the next in a circular pattern. This configuration means the current can travel both ways from either direction, which allows for a balanced load across the circuit. Now let's talk about the radial circuit with a 2.5mm cable and a 20 amp type B MCB. First, we have the consumer unit, which houses the 20 amp MCB type B. It trips if it exceeds the maximum allowance for the fault current, preventing overloads or short circuits. Next, the 2.5mm cable carries the electrical current from the consumer unit to the sockets. This cable is rated to safely handle up to 20 amps of current. The sockets are installed along the circuit. In a radial circuit, the power flows in one direction, starting from the consumer unit and going straight to each socket. Unlike a ring circuit, the power does not loop back to the consumer unit. It simply ends at the last socket in the circuit. And this is the solution we did. This makes the radial circuit simpler, with a single path for the power to flow, compared to the more complex ring circuit that forms a loop.
If you need further explanation, leave the comments down in below and we'll give you that.